Okay, so in the previous class, we understood some key terminologies for IoT, like security, privacy, with and video. We already seen that presentation. Future internet, we understand what is the future internet and the scope. It is also one of the important terminology regarding IoT, and we already seen that the knowledge aggregation. And what is knowledge aggregation? We are getting the accurate data, we are getting a proper data from different data collections. We already seen with the video. And different types of standards, we already understand it. This standards is also one of the key terminologies of IoT. Whenever they are going to manufacture a particular IoT device, they must have certain IoT standards. We already understand it. And regarding sensor networks, sensor network means a network that consisting of collection of sensor nodes. Each node is going to be grab some sensorial data. So, and then the data will be transferred to different areas or different embedded devices to perform a proper task. So that is regarding sensor networks. In so many countries, they are using different types of sensor networks. I already shown with some video presentation to you. And then come to communication. So communication is very important part. We know that the communication will be established whenever the source is making some request for certain data. So immediately the response, this particular server, database server or cloud or any other thing will respond to a particular IoT device. So communication is also one of the key terminology. Communication will be established once uh, once a particular IoT node in an IoT network or sensor network, it is used to make the request. Then what happened? It make the request to any cloud server or any database server SDN. Then what happened? We are getting immediate response from that particular network. And come to the concept of cloud computing. So cloud computing, I will explain with you to video. See here. So let me go for a small video presentation for cloud computing. See here.
Your company has big ideas. To be as efficient as possible while being as profitable as possible. To reach this goal, your company will need business applications, which are usually very expensive and force you to enter a universe of complexity. In the old days, you needed a data center with security, storage, cooling, and power, as well as servers and storage. Plus, let's not forget development, testing, staging, and production, as well as failover and disaster recovery. Cloud computing is a much easier and affordable way to run your business. Instead of running your apps yourself, they can run in a shared data center you just plug in like a utility service. It's much faster to get started and costs far less. Let's compare Gmail to Microsoft Exchange. With Gmail, you don't need servers and storage or a technical team to perform upgrades and keep it all running. With Exchange, you do, and it's not cheap. And Gmail costs less because you don't need to pay for all the people and the products to run them. They're more secure, more reliable, and more scalable than the majority of current applications on the market. Why? Upgrades are performed for you automatically, giving your app security and performance enhancement as well as new features. Even the way you pay for cloud apps is different. You don't have to buy servers and hardware anymore. It's all contained in a predictable monthly cost. Finally, cloud apps don't waste your valuable time, allowing you to focus on more important tasks like growing your company. Cloud computing is an easy way to improve your company's bottom line greatly, while allowing you to work from any smartphone or computer anywhere in the world at any time. For more information, please visit our website at www.wesupportthecloud.com. To be as if it has big.
Okay, students, what we understand in this particular cloud animated video. So cloud computing provides a cluster of servers. So sometimes you, if you establish any particular organization, if you don't have any servers, your applications are developed, then you can pay some money to any cloud providing services or organizations. The clouds will having a lots and lots of storage capacity, as well as there are different types of services will be available. So that's why, so we are not worrying about the security. So it is more reliable while compared to normal storage data networks and storage servers. So they will provide you all the different types of things. For example, if I am a .NET developer, then what happens, I will develop any application. So the application must be deployed in a web server. The server will be there in the clouds, generally all the servers, because if I maintain my own server, then there will be a lots of maintain will be happen. I have to maintain my own servers and all the things will be happen. So that's why I will pay some money to any cloud, then the cloud will provides the maintenance to me, and they will provides an environment for making different types of tasks in that particular tool. So cloud is more reliable and more security while compared to normal servers. If still the company wants to maintain their own servers for more security purpose, they will go for that. But nowadays, cloud computing is also one of the key terminology that is related to IoT, because of what can I say is because of without cloud computing, how can we store lots and lots of amount of data in an IoT using IoT devices? So that is the thing here. So we understand it. And discovery of services, in so many times we have the terminology called discovery of services. That is also one of the key terminologies of IoT. So whenever so many organizations are creating various types of IoT devices, so IoT devices will use different types of services. There are so many IoT devices that will use different types of services. The services will be provided from cloud computing or from fog computing. The services will be available in the servers. So then there are different types of protocols that will be used to discover different types of services, to getting the data, getting the IoT data from various types of services. So that is known as discovery of services. We have different types of protocols are there, discovery protocols that was used in IoT devices. For different types of data will be grabbed to perform different types of actions using the discovery of services. We know that service is a distributable. And next thing is, so nano electronics or nanotechnologies, we already understand it so many times. This nano electronics is a small electronic chips which consisting of small tiny sensors and actuators that will be embedded in small nano, very nano chips. So this type of chips was used to develop different types of computers, and different types of computers and different types of healthcare systems. In a healthcare systems, the human organs, so many times I tell this thing, so please remember that. For example, there are this type of nanotechnologies, this type of nano chips that was used to monitor the health or human organs of a body. So for example, what are the interior parts of the kidney and how that kidney works, how a heart system was works, and these all things will be whenever particular doctors will be insert this particular nano chips into the human body to monitor the internal parts of the human health. So in that particular area, the nano electronics was used. It is a one of the example. So many times I tell this thing. So that is regarding nano electronics. And come to embedded systems. Embedded systems is also one of the key terminologies for IoT. So because of we are telling this because of using, if you want to develop an any IoT system or smart system, we need a collection of IoT devices, or you can say that is network nodes or smart nodes. Collection of all the smart nodes will leads to perform a very great task, that is a smart task. We can also tell that was a smart system. So smart system is developed using different types of embedded systems. So embedded system means a particular chip was developed. We can write a certain program. That program will be fetching into that particular chip. Then we can say that was an embedded system. Embedded system is closely related to key terminologies of the IoT. And next thing is a software. Everyone knows that a software is a sequential set of instructions. Our software is nothing but a collection of programs. Each program is having a set of instructions which is used to perform a proper task. So that means if you want to monitor, manage, organize different types of IoT devices, we have different types of IoT softwares. Like there are lots of environments that was used in IoT. uh, IoT, that is an Android clubbing with Arduino softwares and Raspberry Pi. So we have, there are different types of electronic chips are there, different types of electronic embedded chips we can make using an IoT devices, different collection of IoT devices. That means sensors, actuators, transducers, etc. To create the new embedded systems. So embedded systems is also one of the key terminologies of IoT. So that embedded system can be monitored and managed through the software. So the software is like an Arduino and any other things. And integration of this all components, that means software, hardware related, IoT software, IoT hardware. These all things are clubbed into a single unit. So to perform a great task, to perform a very good task, that is known as a smart system. So the smart system is established through system integration. You can say that was a system integration. So these all are the key terminologies. You can also remember the nanotechnologies, embedded systems, software, system integration, etc. And